So, guys and girls, and all the explorers, welcome back to the show. We have an incredible show on today, and today's guest is a special one. Again, for the people who heard about ISS before or fans of astronauts working on ISS, we're gonna be covering a lot of great topics about ISS because today with us is MATEJ Polacek. So he's a flight operations engineer for the Columbus module of the International Space Station at DLR. So aside from working on existing station, he also worked on habitation concept studies for Moon, Mars, and Venus, collaborating with teams to design bases and necessary systems for these destinations. So the most recent of these, a lunar-based named Domi Inter Astra, so developed with a team from a Space Generation Advisory Council, has won the first place prize in a competition organized by the Moon Society. So congrats on that. Prior to his full-time involvement in human spaceflight, MATEJ worked with the robotics, AI, CubeSats, took part in a 2-week lunar analog mission, and spent a year at the European Space Agency working on software technologies. And of course, you're going to find an Instagram link in the show notes. Make sure to get in contact with this man on Instagram. He has a lot of great content on the feed as well, and that's how we connected as well. So make sure to ask him questions all about how do you get involved with working with the space station, NASA, ESA, all the great questions and anything that we're going to miss here in the show. Look, so MATEJ, I really appreciate you coming on today. Thanks for your time.
Yeah, thanks for having me.
Thank you. It's I've been waiting for this, so I really appreciate you. We couldn't make it the last time, so thanks again for coming over. So look, I want to know, and I think the audience wants to know as well, because we kind of had this short talk before we started recording. Can you tell us your story? How did you get involved right now, and how did you start your career with a flight operations engineer for Columbus module? And maybe you can explain what the Columbus module for International Space Station do also.
Right. So, okay, let's start with the background, I guess. It's easier to talk about than about the life story. So the Columbus module is one of the station modules of the ISS, and this is the European contribution to the International Space Station. So it's an entire pressurized module that can sustain the crew on the inside. It's not just some piece of hardware on the exterior of the station, but it's actually a habitable module, and it's a laboratory module. So the prime purpose of it is to host the science experiments. We have a lot of racks inside that host a lot of payload, different payloads, and the astronauts enter the module mostly to do science experiments and to perform activities in this regard. So there's also a bunch of stuff stowed like it is everywhere in the station, but primarily it's a laboratory module.
Got it. So look, okay, let's talk about the background then.
Right.
Because again, as you said to me before, you weren't destined to work in a space industry, right? You kind of started as as an engineer, and now you work in a flight operations engineer. So how did you end it up, and where people can find these positions? Indeed, Glassdoor, right. Where's that available?
Okay, so it took a bit of deliberation because in Europe we're not as, if I can call it, fortunate, like people in the US are, for example. In the US we have this huge heritage of human space flight. There's a lot of companies working on getting people to space, and of course the US segment of the ISS is much bigger than the one module and some additional hardware that we have on the European side. And there's also much greater legacy, of course, going all the way back to Apollo program and before that even. So let's say in Europe, the positions in this regard, the positions pertaining to astronauts and to humans flying to space, they're a bit more limited. So it takes a bit of, let's say, focus and deliberation. As I said, you have to look for this. You have to maybe position yourself to be able to take this step. And when I originally made the decision that this is the topic that drives me, this is something that I'm really interested in, I want to go in this direction, I didn't have any of this, right? I knew maybe where to look, but I didn't have the skills. And that then also goes back to all the additional stuff that you were talking about in the introduction, the habitation studies. These were all kind of vehicles for me to move in this direction and maybe to learn more about the systems for human spaceflight and understand maybe what the human element in space, how does it influence your design decisions? How does it, how does it change the approach to engineering? And I feel all this was crucial on the road to this job offer, because without that, I wouldn't probably be able to answer the right questions the right way. So as I said, deliberation and the focus. So you have to be looking for these jobs. They open sometimes, they're not open all the time. So I was literally refreshing the DLR website for a couple of months, just looking for something like this. And the first time something like this popped up, I didn't succeed. So then I had to wait another couple of months, and I didn't just wait, like, as I said, I tried to fill the gap with something that would maybe give me a better chance for the next try. So yeah, it's a process for sure. It's not just one event in your life that then puts you in this position, right?
Got it. Exactly. Perseverance
I
goes.
suppose, yeah.
Yeah, exactly. Just continue to, because as I told you before, like I talk with a lot of space enthusiasts, people who are going through analog missions, same as you do. And, we have like after the show or, once we connect and, continue to nurture that relationship, people ask me like, oh, like where do you find these people, and I kind of give them advice. Okay, you're supposed to go on a LinkedIn, or try always to look at for ways to add value to the people first, because there's always going to be people, look, I'm looking for this, I'm looking for that, can you help me? But look, these people are super busy, right? They're super busy and they don't have a lot of time, and I'm pretty sure they'll have another probably 20-30 people asking, can you help me with something? So if you just look for ways to add value to the people first, but as you said, you just have to keep pushing, keep persevering, keep finding the ways, and keep refreshing that feed, to make sure that you find that job, once it's come up.
Absolutely, yeah.
Gotcha. So look, can you explain again for us and for the people, kind of how does the process work? Let's say you wake up, you brush your teeth, you dress up, you go to work. How does the day look like? Is it pretty much the same, or is it like brand new day, brand new stuff? Like, how does this work?
Right. So I'm still in training. So for me, the day is probably a bit more, well, it's a bit different than your usual certified member of the flight control team who's already in the position to operate the systems on board the station. So for me right now, it's and also with the pandemic on top of everything, it's a bit different. So for me, mostly now it consists of home office, where I am required to study the station systems, and especially in terms of Columbus, the payloads as well. And then we have a lot of operational knowledge as well that I need to be familiarized with. So procedures and flight rules, which involve basically they describe how we are supposed to do certain things and how we're not allowed to do certain things. So yeah, this is all the kind of stuff that I'm learning right now. And yeah, other than that, we also have, so I'm kind of shadowing people who already do the job properly in full. So it's like an on-the-job training where I go to work, as you said, get up, brush my teeth, get dressed, and go to work, and then sit next to a team member who's already performing all the tasks properly, in real life, in real time. And they will be explaining what they're doing. And I would be basically asking questions or trying to maybe take over some of the duties. And this way I'm starting to slowly take on responsibility. But yeah, so far what I've seen, every day is different, because of course it's a huge complex system with humans working on board. So you've got a lot of elements that are not constant or consistent, let's say. So there's always something that can go differently, that can happen, in a maybe slightly different fashion than it did before. There's a huge element of planning involved, of course, because it's in everyone's interest to use the station to its maximum potential as much as possible. So yeah, the days are different based on what kind of experiments are scheduled or what kind of activities are scheduled. And maybe a vehicle is docking, like the Soyuz today did, all these things impact the kind of work that's being done by the flight control team on the ground. So yeah, there's always something new, something different to consider, some variations on the usual shift. So it's really interesting.
Gotcha. So how does the teamwork look like? I mean, because I'm pretty sure there's a lot of creative, smart people who work around you. So how do you feel this team vibe? Like, is there a feeling to it? Like, what does it look like comparing to the like cubicle type of job?
Right. I guess it's difficult to gauge right now, especially since we're required to maintain certain distance, because of course we have a limited number of people who can perform this job. So it's not it's really not a great idea to like spread the potential viruses among ourselves, because then if the whole team went on a sick leave, then there would be no one to fly the station, right?
And that's not good.
That's not good, of course. But yeah, it's really difficult for me to kind of understand that, because I started only in December, and yeah, it's already been this crazy kind of mode of working from home and kind of maintaining distance. But for sure, there's an element of like office work where, because it's not just the console work, it's not just the real-time stuff, right? It's also kind of managing the information you maybe gather on the shift, and you know, you gain some knowledge as you go. You maybe face situations you haven't seen before. Maybe something isn't working as it should, and this all has to be recorded, and then it has to be processed, maybe analyzed. So there is this kind of offline element to it as well. So I guess it's a mix of both, right? This real time on the console shift work, plus also not cubicle per se, but kind of more traditional office style job. And yeah, it's an interesting combination. And yeah, as I said, the shifts really keep it lively. There's always a lot of going on, and it's been a bunch of times where I went for a shift and someone told me, this is supposed to be a camp shift. We can go over a bunch of things. You know, you can learn a lot of things. And then I've not seen a camp shift yet. There's always something going on. So yeah, that's really exciting for me because it's you know, you learn something new every day, and there's a lot of things to learn. And yeah, to me, that's the most interesting part of it, because you don't get kind of stuck in certain way of things, but you always kind of develop, and that I think is really cool.
Exactly. So, you know, I spoke with a few people from NASA who one of those working right now as a engineer on Hermes, I think, you know, on lunar lander, just like I think on one of the modules. So he works on that. So he said he talked about the importance of finding mentors and how that helped him personally, like when he started as an intern also, and you know, he was looking for somebody to get the guidance and information, the knowledge. So that really helped him a lot. So do you feel the same way, like once you start to work with, you know, with these type of projects, that you should pick up one or two people and kind of ask them questions? Okay, can you take me under the wing and kind of explain and take me further, you know, so I can learn faster and more?
So this is something I contemplated for a while, because you know, all my peers and people like in the industry around me, they always talked about, you know, finding mentors for that, finding mentors for this and that, you know, and like I always, well, right, I never really made the decision to find a mentor, and I never found someone who would be like, you know, this one guy or this one person who's like who I go to advise consistently. So I wouldn't say I had a traditional mentor in this. I certainly think it's a good thing to have someone, especially if it's someone really closely related to what you want to be doing and can really give you some advice, you know, how to reach the goals and how to get to the destination that you want to go. But me, myself, I think I had to piece this together from many different people, you know, that I came across, you know, and I would ask some advice here, some advice there. I don't. It's certainly a form of mentorship, but I don't think these people would say that they were my mentor, because I never really approached them in that fashion. You know, like, could you please now stick with me for a couple, I don't know, weeks, months, and help me with this? I don't know. I never did that, so I don't know.
Got it. So when does this internship like phase will finish for you, and when do you think you're going to be full time working with them?
Right, so it's not an internship per se. I'm already full-time employed. It's more about a training phase, you know. Okay. So it's really about getting the required skills, and then that ends with a certification. So once the team member is certified, then they're allowed to take on these tasks on their own and, you know, perform the job fully. So this is a standard procedure for everyone. And yeah, it's I mean, it's to a degree, it's such a niche job that you have to have this. This is not something I guess you can prepare for on your own or at university. It's really in-depth dive into the systems of the station and into the procedures, which I don't even know if you could maybe find yourself on the internet or anywhere. So
gotcha.
Yeah, it's definitely a part of the job already.
Yeah. So how many people besides you, I mean, working as a flight operations engineer currently with you?
Right. So we, as a team, as the flight control team, we staff different positions. So the position I'm on is called Stratus, and that's basically the commanding and the main monitoring position for the systems. So these are the people who you know, monitor the telemetry 24/7, and then when there's some actions to be performed, they're the ones who send the commands to the station from the ground to perform. Could be activating equipment, deactivating equipment, you know, sorting data lines so that the data is sent properly from an experiment to ground, and, you know, similar things. And also then monitoring this equipment to make sure that it's performing what it's supposed to be performing and is not maybe entering into some sort of configuration that could be harmful both for the hardware or for the crew. So yeah, there's like limits for voltages, for temperatures, and this is all the stuff you have to keep your eye on. Yeah. And of course, then each of these positions is staffed by several people. So if you have to cover a position 24/7, then of course it can be up to like 1 or 2 people, right? There's a whole range of team members who then take shifts and cover these positions. And yeah, I guess just to give you an idea of what the other positions look like. So there's a position who's completely focused on stowage. So they keep track of equipment inside of Columbus. And then we, of course, have equivalents in the other parts of the stations that do similar things, right? Mm-hmm. And they make sure that if the astronauts need to find some tool or some material or some, I don't know, some stuff for the experiment, they know where to point them so that they don't have to go rummaging through all the things, right? They just tell them, okay, it should be over there and you can find it, collect it from there and then use it for this experiment. I said before that there's a huge element of planning involved. That's, again, a separate kind of a sub-team which then staff certain positions and they look at different time periods for the module. So it could be planning for anything from like a week to the entire half a year ahead of us. So yeah, I'm just trying to make sure that the time is used properly. And yeah, there's a bunch of other positions just trying to make sure everything runs smoothly. So there's also a ground control team which makes sure that our computers work properly and then we have all the right connections, and then we can communicate both with NASA in Houston and also the station. So lot of small moving parts that have to be running smoothly.
I think that the question that a lot of people would love to ask, including myself, have you had a chance, again, even though you're working in this position, have you had a chance to talk with some of the astronauts, on
right.
ISS currently?
So, okay, so going back to what I was talking about before, there's a position for this, and it's not me, right? Or the position I'm training for, right? There's a separate position called Eurocom, which is the European communicator with the astronauts on board. And the NASA equivalent of this is called Capcom, which may be a familiar term. And basically, these are the dedicated team positions who are tasked with, conveying information between the astronauts and the flight control team on the ground. Mm-hmm. However, we do listen to astronauts as they communicate either with NASA or with these positions, because it makes things easier both for the Eurocom guy or for everyone in the team, if we are already aware of the situation or of whatever needs or questions they might have. So yeah, we listen to them in the real time, but we don't speak to them per se.
Got it. So in the position that you're currently in, so again, congratulations on that. So do you feel like now when you see all the different positions that your teammates are working in, and again, one of those are working with talking with astronauts, other one is doing some other things, do you believe like you are personally right now in the right position, or maybe you're seeing some of the teammates and you're thinking, man, I would love to do that instead?
Right. I think okay, I was given a bit of a choice when I was joining this team. So there was an option for me to maybe go more towards the planning or stay in this position. And even the management guys who were asking me this question, they already kind of sensed which way I will go, and this is the way I went. And that's because my background is in engineering, right? So it's more on the technical side of things and more kind of closer to the hardware and working with the systems. So I mean, they guessed that already as well themselves when I was applying, and of course for me that was kind of a no-brainer, because it's closer to the kind of work that I did before, working with the actual systems rather than the other positions that I named.
Gotcha. So what would you say is like personally benefits you the most for this particular position? Because you have an experience, again, robotics, AI, CubeSats, analog missions. So like for this position, what would you say was kind of the one thing that you did in the past that benefits you the most?
That's actually really hard to pinpoint for me, because I mean, the analog missions, for example, they're great. And I felt like it was a great test for myself to understand, where my limits are, or like, how far I can go. I still don't think I found the limits, but the analog was a great test of that, to see how far I can go, and it was great. But at the same time, it's not really based in the sense of operational expertise that the team here uses, right? The procedures and the methods, they're a bit different. So Yeah, maybe it was a great personality test in the sense that, I didn't really feel stressed in this analog mission. I could, maybe alter my working hours a bit, because that's what we did during our mission. We kind of slowly shifted. We had some early raises, and this all is, of course, important for this kind of job, but it's not maybe a direct kind of expertise booster, let's say, for this kind of application. Yeah. And then from the other stuff, I guess it's a mix of things, right? Again, working on these habitation studies, it teaches you things about, as I mentioned before, it teaches you how the human spaceflight systems work. It makes you read papers on how the systems on the station work, and you try to look for some analogies that you could then use on, say, the moon or Mars. What do we know from the ISS that we can then kind of extrapolate into a system on the moon or Mars? And you already start to familiarize yourself with things that could be handy for this kind of job. And it always looks good on your CV when you can say that you have some sort of knowledge of human spaceflight systems. And yeah, with robotics, again, it was more about one part of the job, right? So like working with the hardware and software is great, but that's not really that central to my current job. But then again, as a small company, when I was working with robotics, we did a lot of tests in the field ourselves. And again, this is something which kind of taps into the operations a little bit, maybe. So, again, something that you can mention in the interview. And yeah, it's a lot of tiny little skills coming together. If that's the kind of message I'm trying to give you here.
Got it, got it. So what would you say for the people, I mean, who are looking for similar positions without, of course, persevering or, refreshing the feed on a job section? Like, what would you say, like, as far as you see, again, from your own personal life, so the job that you got, kind of explain what did it take for you personal, and what type of strengths from the past, benefit you to find this job, and maybe from your teammates. Like, of course, probably you talk, I don't know how in depth you talk about their own personal background and what type of situations and, scenarios they were going through, what type of experience they have. But what you recommend for people who are watching or listening, they're young, 18, 19, 20, they want to get involved with this. Like, what will be the right skill sets to acquire if they're starting from kind of zero?
Right. If you're starting from zero, then don't do the mistake I did and actually go study aerospace engineering, because I didn't. And I think, well, I'm still not sure where I would have been if I studied aerospace engineering. Maybe I would have realized or maybe I would have grown sick of it and I would be doing something else right now. But at the same time, I feel like this has been a bit of a hurdle for me to a degree, like making sure that I can show that you don't have to be an aerospace engineer to maybe slowly acquire these skills and then move in this direction as well. So yeah, my first advice would be actually choose your degree correctly and go for what interests you. I mean, I really liked what I studied. I enjoyed it. It gave me interesting skill set, from maths, which I maybe didn't enjoy as much at first. I came to appreciate it later when I was working with AI, and then I really only found myself, let's say, in the software field. But then through the software, I could start working in robotics, which, it's a difficult, one thing leads to another, and it's hard to say if this was really such a crucial moment for me. But I feel, you could always know more. And if you want to go into aerospace engineering, then don't be silly and study aerospace engineering. That's the first thing I would say. Yeah. And then, of course, it's about the projects, so if you feel like something's lacking, if you feel like you want to move towards a field that maybe you're not equipped for, just find some projects that will give you those skills, and then treat them with this kind of seriousness, right? Because I mean, you can be doing projects, and if you treat them as kind of like toy exercises, then maybe they don't give you as much as if you treat them as a potential project you could publish, or something that you kind of treat more seriously and really dive into the research and try to yeah, A, build something, but B, also use it to propel yourself forwards and learn more. So yeah, spare time is a good way to build on top of what you learn at uni.
Yeah, great. So you definitely, like, by the way it sounds, that you really have to be dedicated to this, like taking the spare time instead of going again, maybe in these, times that we're living in, going in the cinema or a cafe, maybe it doesn't work. So now I think it's a really great time to kind of get in the books, continue to learn and educate yourself. If you're really passionate about, things that you're doing, because maybe somebody will take a completely different direction. Like I talk with the people who work in NASA, and they started to work with NASA as a contractor, supplying different parts, for satellites and things like that. And they got a position at NASA. They worked as, let's say, engineer and some of the parts, and then they moved to a different position, and now they're working in a completely different position. And now they found themselves there in the best place ever. This is what I want to do. So maybe it's going to be a journey there as well, once you're going to be working inside the company too. So, but it's definitely like having all that experiences you're talking about, as much as you probably can to collect it. It definitely will benefit you, tremendously. What would you say again, now working as the insider, on ISS on a Columbus module, like, what have you heard, that would be like, okay, I heard about the SS a little bit. I think I know a little bit of information, but like that part, like I never heard about that before. That kind of blows my mind.
Oh, wow. That's a tough question. I mean, in this training that I'm going through right now, you get so immersed that I can't really even tell you something like this. And at the same time, I'm wondering if I should be, if there was something this juicy, right? But
we're gonna cut it out. We're gonna cut it out just for me.
Nothing that really comes to my mind, but I guess, before I would be hearing about the ISS from the news all the time, and I guess finally working on the inside, as you put it, I kind of appreciate it a bit more, right? Because this news kind of impacts me now, impacts the job that I'm doing. So I kind of pay a bit more attention to it right now. And it's, I think after 20 years of it being in operation, we kind of start taking it for granted. If we, everyone has their own life to go through, they have their own responsibilities and duties. And they sometimes hear about the ISS and they're like, yeah, that's cool, that's awesome. But maybe they don't stop to think how incredible of an achievement it is, how many people are involved. And even after 20 years, there's still firsts, every now and then, people achieve things that maybe they didn't even think of when the station was first launched, and yeah, it kind of, maybe it's not like, there's this one big juicy thing I can talk about, but it's the whole station as a whole. I mean, I came to appreciate it a bit more.
Gotcha. So again, as I mentioned, 20 years, at least for now, look great. Everything works fine, and we continue to do important research on ISS. So this is great, 20 years. So do we have another 20-year plan for ISS? I mean, because everything has a kind of, timeline, and everything has an end date. Again, we had a Hubble Space Telescope. Again, everything breaks, and thank God we have, astronauts doing the spacewalks, which of course they can work on these, fixing parts. It's not like you have to take a space shuttle to fix, the Space Telescope. So this is great, but when do you think is going to be kind of the end of it? And are we actually thinking about creating a brand new station at some point?
Right. So that's again a very, I would say, philosophical question, because we've had deadlines before. NASA has said before that it's going to be this amount of years, and then the station is going to be deorbited, and that's it.
So what does the NASA say? How many years?
Before it was, I don't remember what was the last deadline they gave, but that's already been kind of surpassed.
Okay.
Right now, I think they say that by the end of the decade they will want to deorbit the ISS.
Any particular reasons for that?
It's expensive to operate the station. That's one thing. Second thing is, the modules have their lifetime, and I think that's maybe starting to show a little bit on the Russian segment, where you probably heard about the leak on the Russian segment, and of course the Russians at the same time don't take it lightly, right? They're working on new modules. They want to replace them. They want to maybe deorbit some parts of the station, but replace it with new modern modules. So it's not like you have to deorbit the whole station to fix this problem, if it's a problem at all. I mean, because
Russians will continue to use the technology. Look, it's the Soyuz behind you. With all these years, they're still going with it.
Yeah. So I don't think deorbiting is the only solution, and we've seen that before, right? The NASA decided to extend the lifetime because they had the reasons to continue using the station. So it really is, 9 years is a long time, even in space industry where projects can take a long time. But Still, it's too far to say if this is going to be actually the case or if they decide to take a different course of action. So I don't really think this is an important discussion for us mortals to have right now. We'll see what happens we'll see what happens with the agencies in the couple of years and what direction they decide to take. But you asked about other stations, and yeah, this is maybe the most interesting thing in this direction, and that NASA actually awarded contracts to private company. It's called Axiom. You can look it up, but yeah, they actually awarded a contract to them to start building their own kind of a private space station. I say private because it is actually going to be built by a private company. So in terms of ownership, it's I suppose going to be similar to what SpaceX is doing, right? So it's going to be their own property. It's not going to be a NASA built station. Although I'm not a space lawyer, maybe I'm getting it totally wrong. But what they're trying to do and what their plan is currently, if you look up their plans, they have a nice video showing what they want to do, and they actually want to use the International Space Station as a kind of springboard, if I can call it that, right? They want to launch their modules to the ISS and then construct their station off the ISS, and then once their station is self-sufficient, they'll detach and they will fly the station separately. And I think even more recently, there's been an announcement by the Sierra Nevada Corporation. They are currently working on a space plane that's meant to be supplying the station both as a cargo vehicle and as a
Dream Chaser.
Dream Chaser, correctly. And they also want to fly astronauts in this Dream Chaser. But they've announced also some plans to build their own space station. But I haven't had a chance to look into more details because it's very recent, I think.
Got it. So with the Axiom, because I'm just looking at the image, and again, you guys and girls can find the image if you just type in Axiom Space Station. I think I see like 7 modules, and I'm not sure what size they're going to be. I need to go into detail on that, but it looks very interesting because you can see that like one big square. Have you seen the image? Have you seen it? Probably.
Yeah, I've seen. They've also recently published some interiors. Yeah, it's. I think. Well, the vibe I get from the visualization is that they want to serve more the commercial space flight, the space tourism, and these kind of branches of space industry. So, ISS currently is a very let's say Spartan installation, right? There's cables everywhere. There's a lot of experiments floating around. There's a lot of experiments in every single inch of the station. So, yeah, it's
look,
very.
That's what the station's supposed to be for, I think.
Precisely, it's very utilitarian, and yeah, it's going to be curious to see where these private companies will want to take these stations, because of course they'll have to make it, if not profitable, then at least feasible. So
we're talking about creating those type of space stations for space tourism instead of doing important research. So do you think going in the future is a good thing to take this kind of right turn from doing the research that makes things better here on the planet, taking into, okay, let's charge people 300,000 and let's make the space accessible to day-to-day people?
I want to be optimistic, and I think, once you are in charge of such an asset, yeah, and you have access to your own private space station, I think there is going to be opportunity also for science and also for all these science. Kind of, yeah, it could be, it's well possible that NASA is just going to pay them, again, contracts to conduct experiments on board, right? Or maybe some of the tourist slots will be taken by astronauts. I mean, it's really early to say, again, to what's going to be the utilization of the station. But yeah, just flying tourists up and down, that would be very black and white to me, in contrast to what we have in terms of the ISS, and just going into pure space tourism. I think that would be a very big departure from what we know about space stations and how we operate them right now. So I think, and I want to believe, again, my personal opinion, but I want to believe that there will be some sort of hybrid model where we'll be able to do some research also with these private stations, but also they'll serve a bit more, let's say, leisurely purposes like space tourism and stuff like that. What maybe an interesting thing to highlight is that for the ISS right now, we don't just use the internal volume of the station, right? There's a lot of experiments on the outside of the station as well, right? There's external payload facilities which are exposing experiments or to the hard vacuum of space, to the radiation of space. There's also experiments that are monitoring the atmosphere of Earth through, by being on the outside shell of the station. So even if you're flying a private space station and you just want to use your full internal volume for the tourists, there's still plenty of opportunities to be doing science on the outside, because you can, there's no point not using that outside shell for something and generating some more money if that's what you're after.
Yeah, I think Axiom should, collaborate if that's possible with NASA, instead of NASA collaborating with Axiom and, letting them run the space station. And, why build a brand new station if we already have the one? Of course, as you talked about the leaks that are happening, which of course, astronauts are working on that. But it doesn't make a lot of sense. I mean, if things do work, why take it down? Because, it's a huge infrastructure. We put a lot of, we as people will put a lot of money, time, effort into this. There's a lot of really genius type of people who could put this together, and it's probably one of the biggest achievements when it comes to space science that we have. Like it goes right there with Apollo missions. So having that and getting rid of that, let's say in the next 10 years, and having something private where there's a private company runs that, it's an asset now, suddenly becomes that, and it's being used as that to create income. So like, do you believe, like, going further in the future, because I had more than a few people where we talked about, again, space tourism and business, and again what's happening with the SpaceX, Blue Origin. Like, we have a lot of private companies getting kickstarting and getting involved in the space industry. So do you believe that we should treat space as the business, or it's still possible for us to treat the space just from the sake of a kind of exploration, or this is kind of not possible to turn it back around, and it's a economically driven industry also?
Okay, I think that what makes sense is that if these companies take over and maybe cover some aspect of the exploration, right? Because the same way you can go out there today and buy a private plane, and you can go start exploring the Amazon or something, right? That's great. That's an enabler, right? It's not prohibitively expensive for you to maybe save up enough money and buy some single engine plane and start exploring the world on your own, whatever your agenda might be. If you want to do this academically, or if you want to write a book or something, you have this option, given that you can earn enough money, and that money is attainable to more and more people, because the plane is built in series. It doesn't have to be built by a specialized agency for this one particular purpose, and it doesn't therefore cost tens and hundreds of millions. Yeah. So I think this is the kind of similar approach with SpaceX and these other launcher companies, that you offload this necessity of developing the launchers in-house, like was the case maybe with some historical launchers, but having the serial kind of optimized production of these vehicles then makes it cheaper, and also takes some of the load of the agency, who then can focus on the exploration itself. And it's hard to say if this is the tipping point, but imagine if we drew a parallel between a boat and a space station, right? Like, if you build the first steamboat and then decided that you're just going to maintain this steamboat forever because it's a huge achievement, it costs lots of money to develop, where do you draw the line and decide that maybe now it's time to start building more and more of these, and like use them for different things and give them to different people? I fully understand where you're coming from and what you're worried about this privatization and how it might be curbing the exploration aspect, and like the science that benefits us all. But I'm pretty sure that as I said, there will be ways of utilizing this for more than just private endeavors. I'm sure agencies will be interested and will be willing to spend money, which these companies will be interested to take in, because they're now operating a space station, which is super expensive, as we know. So they'll be finding ways how to make this at least feasible. And I'm sure that's going to, again, the companies will be interested in making this as lean as possible, so they're not bleeding money where they don't have to. And the agencies will therefore only have to worry about the science and leave the entire management aspect to someone else, or maybe take the role of the station manager, but then again, that opens door for more collaboration, for more maybe payments in kind. So, NASA comes in and says, okay, we'll fly your station because we have now 20 years of expertise flying a station. But for that, we want a module and we want to have our experiments there. There's different ways you could picture this collaboration. And as I said, I don't think it's black and white in the sense that we have a agency space station now and we'll only have a private station that's off limits for everyone else in the next 10 years, right? I think there's going to be some sort of transition between these two modes. And yeah, as I said, maybe eventually there will be private space stations that are fully off limits and maybe some rich guy is flying his own little module in orbit. But yeah, I think that's far in the future, and before that happens,
we should keep it for the movies. This type of scenario it works great in the movies,
Yeah, for Bond villains and similar.
Yeah. So look, I love your perspective, and I think that's the way it should work out. And again, for your sake and for my sake, hopefully, look, because I don't want to see it black and white either. But I'm just asking your personal perspective, the way you see this industry to unfold, because there's a lot of problems with it right now. Again, just looking again, and space station had these problems, close encounters with space debris. I think like 7 or 6 times this year, almost hitting the space station. So we already have some problems. So besides these small problems, which of course are piling up and it's becoming this huge problem, the space debris, what other things we may encounter? And again, there's multiple scenarios, but hopefully, again, looking from a positive lens, hopefully everything is going to work out as you just said. So look, I want to ask you a question about I love the piece where people talk about, taking people as a space tourist, for a flight in a, lower orbit, or taking them to the moon. Again, what's happening now with the SpaceX in collaboration with the Japanese billionaire. Like, I love those type of things. So, and you've been working on habitation, like stations for Moon, Mars, and Venus. So can you talk about that process? And I know that you now have lunar base named Domi Inter Astra, which again won the first prize. So can you talk about that? Because I have this open as well. Again, I will include that for you guys and girls, so you can open that PDF. You can download it pretty sure to the phone. And it's very interesting design. So can you explain, first of all, how does design works? Why have you picked this one? And how did you win this entire thing?
Right. So for these competitions and for these habitation studies, I've so far worked always as a part of a team, right? And for both Venus and for the lunar competition, we were quite a big team of 15, 20 people maybe. So what we do is kind of break down the work into smaller fields in which we are maybe a bit more specialized and have a better perspective on things. So my role usually in these things falls down to robotics, the EVAs, and maybe with a lick of science, or maybe the part of the operations and utilization. So, what's how do we use this station to actually generate some return, science return especially. So yes, for the lunar project, we decided, of course, we were given certain rules to follow. There were some crew sizes that we had to work with, and some constraints that we had to meet. So yeah, most of it stemmed from the fact that we were looking in the near future. So we didn't want to go too wild with the launchers that, we used we only use launchers that we know exist now and that might exist in a couple of years, but nothing too wildly sci-fi, nothing extreme. So I think the biggest we considered was the SpaceX Starship. And after that is just an iterative work of the construction team, of the power team. Then there's also the architectural constraints. So you have some limits of how you can build in these locations, but also how do you bring the materials and how do you put them together. So it's a kind of an iterative process that goes around the room a bunch of times, to make sure that when you change something in one of the systems, you don't violate something on the other side, and if you want to fly this kind of material for your construction, can you actually carry that in your rockets? And isn't it too heavy, or isn't it isn't it going to be too expensive, taking up tens of launches? This is kind of process of trying to find the balance between different pieces. And for the robotics, the interesting part for me was that we decided to go with a fully automated initial phase. So we came up with this concept of a rover that's based on a real robotic platform you can go and buy today. And of course, we would have to adapt it for the space environment, and of course, we would want to adapt because it's just a platform, so we want to give it some capability of being able to conduct the tasks that we have in front of us when building the station. So yeah, we came up with an interface. We used some inspiration again from the ISS, how to maybe switch tools on a platform, so we did a little analogy with the Canadarm, with the robotic arm we have on the ISS. And then yeah, we put together some power requirements, some labor, how much work we can do in this kind of configuration, and preparing the ground for the construction, setting up power lines, setting up solar arrays, this sort of thing. And how do you do that with a rover, and how do you do it with rovers so that you don't have to bring 50 of them, and how can you overlap the tasks in a way that you save as much space and save as much mass, and therefore you have the least amount of launches to get all this on site. So yeah, it's a nice exercise in this sort of regard. And of course, then you start thinking about humans in the base, and
that's the biggest problem.
How do you bring the visitors from the landing site to the habitat, and you start thinking about operations and how do you want to utilize spacesuits, and how do you want to make sure that they don't bring too much lunar dust inside, and should you be using suit locks instead of typical air locks that we have on the ISS right now? You start familiarizing yourself with technologies and find the best solutions, and yeah, it's all great. It's a lot of fun and good exercise.
So do you think, again, because I'm just looking at the photo and I see the solar arrays kind of being deployed on a upper hill on the mountain, and I see as far as the habitat, it stands either on the surface or in the crater. So do you think that would be a good position? Because again, I talk with a lot of people who working with these projects as well, and they coming up with their own ideas how the habitat's supposed to look like. Also, a lot of people say kind of using the lava tubes is a good option. Some people say use the crater. So why have you picked, like, it's either the surface or the crater? Maybe you can explain.
Right. So for us, it was a trade-off again between, there was an entire trade-off done by one of our team members, and she looked into how much sunlight do we get in particular spots, and also what's in the vicinity, of course, if there's anything interesting, because we are interested in the permanently shadowed regions for potential ice and water, therefore. But at the same time, we have to be realistic with the topology, right? So we were looking at an inside of a crater for some time, but then it turns out that there's a really steep incline on the way there, and that would have been very complicated to work with in terms of construction. And yeah, even getting the astronauts or the visitors there, would be very complex. So that ruled out some of the craters as a location. So yeah, you're basically looking for these kind of points of interest, and you want to make sure that you're not, say, obstructed by any features that might be prohibitive for what you're trying to achieve.
So what would you say was the most difficult part that was really hard for you guys as a team to figure out? I'm pretty sure you found the answers to all the things, but maybe this one you kind of jinxed it. You was like, I think that would work, but we not kind of sure.
I think it was the right. Okay, I don't want to say any part of it was more difficult than the rest of it, because I said we had a lot of people working on it, and a lot of them brought their expertise into the play. So everyone knew what they were doing, and even then the interplay and the cooperation worked really smoothly, because yeah, we had team leads who then made sure that the interfacing between the teams is working well, and that people collaborate well, and there's no like I don't want to use the word conflicts, but like, let's say that there isn't any issues with how we want to put these systems together, and I think that worked really well. The biggest kind of question is, of course, how did you get the stuff there? Because that's I would say probably even now, even for our present reality, that's the biggest issue. It's expensive to launch things to the moon. The launcher tech is expensive. It's a it's a long process developing these things, and then also making them big enough to be able to reach the moon with some useful payload to then offload. I think that's the biggest issue also for us. Let's say in reality, yeah. So that's always when you count those launches and you're looking at the tally of how much it takes to get all the stuff there, you're kind of like, yeah, this is going to be tough.
Look, you already got the design, you got already laid out. I mean, it's 21 pages of in detail of how you're going to build this. So now it's up to Elon to figure out how to lower the cost to launch. And, you can already tell him, like, we got this. Now it's up to you. You have to figure things out because we need to take this up and start to build this. So do you believe, again, the habitats, like with the, right now, the NASA's mission, the Artemis mission is kind of going to be a breakthrough one. Again, first woman on the moon is going to be phenomenal also. Do you believe it will come through, again, coming back to the same question, kind of from private space sector, or it's going to be something from a space agency when we're talking about the lunar habitats?
Right.
Or combination of both?
You heard me talk about black and white things before, and I always tell you that it's going to be a bit of both, probably. So, yeah, not to make it sound like a cop out that I'm just going to say both, but
it's kind of the same question.
Of course it is, but yeah, what I was going to say as well before with the stations is that maybe NASA letting go of the ISS is also a good thing for it to set its eyes and for its astronauts to set its eyes further, right? Because the opponents of the ISS will tell you that we've been stuck in the low Earth orbit for decades now, and that we haven't been anywhere further with the humans for a while. And why do we stay in the LEO when we already been to the moon? Why don't we go further? Why don't we go to Mars? And etc. etc. It's an ongoing discussion for some people. Why not push the frontier? Why not go further? And on one hand, you can say that, yes, we need to learn more about how humans function in space before we take them on long trips. And going to Mars is a very long trip. So, yeah, that's why we have the ISS. That's why we put people like Scott Kelly on the ISS for a year and try to understand what happens to him over such a long duration. So that we are ready when the time comes to actually send someone to Mars, and not be surprised by all the impact that the trip itself had on their body. So yeah, there's always there's of course an argument for, and there's also of course argument against, and people want to be kind of bullish with this and want to press forward, but at the same time the agency is the one taking the responsibility for these lives, and imagine the PR nightmare if they actually lost the crew on the first trip to Mars. It's like no one wants to take that responsibility. So of course the agencies want to take it step by step so that they are ready for the next milestone. And yeah, I think the moon is a great I don't want to say compromise, but it's the great next step, especially if we're talking a long-term sustained exploration and sustained presence eventually, I hope. So yeah, we've been to the moon, but we've always only been there for a short while. So yeah, the next step is to do with the moon what we've done with LEO, put people there long term. And yeah, we already see the involvement of private companies. They're playing a key role in developing the hardware, in scoring contracts from NASA and making sure we have the hardware to go there. So that's, I would say, kind of standard these days anyway. It's been standard before as well. There's always been companies delivering these things.
Yep.
The question is if any of these companies is going to take over any of these capacities or these capabilities full time. Are they going to be interested in maybe running some part of the lunar infrastructure full time?
Yeah, exactly. So we're coming back to the same kind of point, which like when I talk with people like yourself who are particularly working, on the engineering side, and we talk about lunar habitats, living on Mars, we always come back to the same conclusion, which again, having technology seems like it's a big issue now, because we're talking about creating a lunar base, which again has never been done before. And I talk with people from NASA, they're like, look, it's never been done before. So once you have this idea, and it's never been done before, it will take time, money, effort. A lot of people will get involved in this, and it will definitely take a lot of time. And that's what he said. But the biggest issue is, again, as you talked about, taking long flights, staying for a long time. And again, we had one of the US people, Scott Kelly, for 340 something days. I think the first one is crazy. Of course, the Russians have to be first on that because they have some crazy people, and I think he's 300 probably a year in there somewhere, staying on ISS. I don't know, spoke with somebody who talked about RNA imaging tools, which basically helps them to see, because once the Scott Kelly came back to the Earth, they took the samples basically of his body. They did all the testing, like I think after a first day, a second day, after a week, there was a time. But, he said that there's actually available tools to do research, through DNA to make sure what type of impact astronauts getting live once they in a microgravity. So, like, do you believe, there is possible to solve this problem? Because again, traveling to Mars for 7 months and then coming back for another 7 months, like it's not have been done before. So do you believe like it's achievable? Like we need some sort of a technology, just from a space enthusiast kind of point. What do you believe we need to, to achieve this type of thing?
Right. So I think the biggest issue we have to overcome is, if you read Scott Kelly's book, he's some of the opening chapters, they go on about how he upon return to Earth, had issues with such a trivial thing like sleeping, because sleeping in the microgravity for so long, his body got used to or forgot, that when you sleep on Earth, you actually are constantly pressed against your bed, right?
Yeah.
And yeah, it would be painful for him to sleep in his bed because his body, lost that strength, let's say, yeah, or that resilience. So, and now you take that and translate it to a crew on Mars who's sent there. They're the furthest they've ever gone from Earth, and suddenly they have to land on Mars and start working on some science or on some construction. How do you reconcile that? It's if we just did what we did with Scott Kelly, and send them in a tin can on a 7-month trip, they'd get there and they'd probably have problems performing basic duties, or maybe they wouldn't be based on the decreased gravity, but there's still that risk, that they would get off that ship and they wouldn't be able to perform anything because suddenly they're again under influence of a gravitational force. So, do you want to take that risk? I think if you're NASA, I probably don't want to take that risk without any prior, let's say, studies and prior knowledge. So, yeah, but at the same time, there are ways how to mitigate this, right? And you can induce some forces in transit by spinning up your ship, for example, or making some sort of, we've all seen The Martian, right? Where they have this kind of centrifugal part of their spaceship. So, I think there are ways to solve problems like these, and you can look at Apollo, how people solved problems then, and how fast they managed to go from no human in space to humans on lunar surface, right? So I think given the right kind of incentive and the right kind of, especially funding, which was the case for Apollo, maybe isn't so much the case right now, you can solve many problems, and you can tackle many of these things that might seem like showstoppers now, but really are just it's just a question of trying and gaining the right amount of knowledge and expertise before undertaking this huge trip. So
exactly.
it's
So
certainly doable.
Yeah, once you talked about the movie The Martian, I remember. Do you know there is a company they're looking to build until 2027? It's by Orbital Assembly. They're looking to build this space hotel. Have you seen it?
Oh yeah, I've seen it. Yes.
Yeah. Do you think that's achievable? Because I would love to go there. It looks nice.
It's a bold time frame. I will get that out of the way first and foremost. But and also the scope of the thing. I mean, again, they're pushing quite a few frontiers with the size of the whole thing. And
Do you think it's too big?
I don't think it's too big. It's just big, right? No one's built anything that big in orbit, and especially not for humans. So I wish them all the luck, because I would love to see it in place and in operation. It's just extremely bold, I think, and I hope they have all the talent in the house they need to pull it off, because that would be really exciting to see. So yeah, it's hard for me to say as an outsider to their company if it's possible or not, but I hope they're right, and I hope they can do it.
Got you. Of course, because I'm one of those people just like you who is looking forward to these moments. Again, we talk and talk, and I think this talk has been going for quite a long time. I remember I posted this quote on social media, and I can't remember who said that. I think it was a lady. She was I think she was part of the science, just the science communicator. And she said that quote about that the space is going to become a next thing, like tomorrow. And that was quote from 1960 or 1970s. So we've been talking about this becoming space is going to be the next thing tomorrow. It's going to be this. We're going to have, tourists, on Mars or on the moon, which of course it's good to keep people excited because that's how we're going to push these projects further. But just like Elon Musk said, he's not always good with the timelines. He always say it's going to be 2021 and then it's 2031. But look, once we keep it going and once we have something like is just had bold goals, because I think that's the way to go when it comes to space. Like you said, building a new space station, because why not? Creating a space, hotel, building a lunar base. So when do you think is going to happen this, come talking about the timelines, Mars scenario now? Because, there's a lot of eyeballs and a lot of years about this topic. I just want to get your personal take. Like, do you believe it's going to happen 20 years, 50 years? Like, what's the timeline, first of all?
I think I actually bet on this, but I don't now remember what year I said, because of course that was a couple of years ago, and I think it will sound foolish if I say it again.
We're gonna try.
So I don't want to. I don't want to go back to that bet, because I think that might sound foolish now. I want to be optimistic. I mean, I guess that's the vibe of all my answers, to optimism. Yeah. But let's say 30s, 2030s. I'm going to be hopeful and say that. I'd be happy if I'm proven wrong and it's going to be earlier. But equally, as much, I'm ready to be, well, let's not say disappointed, because I work in the space industry and delays are commonplace. So if something realistic happens, and it's later, then I guess that's okay as well.
That's no problem. Yeah, it's Mars is not rushing anywhere. It's still going to be there after 100 years. So, that's fine. We just have to take our time.
I'm more excited for the lunar race, let's say. Yeah, I think that's a much more achievable goal. And there's already things in motion, with Lunar Gateway and with all these NASA contracts for the landers, And again, it's about paving the way. And if we can pave the way to the moon in a sustainable way, that we can repeat over and over, that's going to teach us so many things that can be reused for Mars or, Venus as well, right? Nobody talks about Venus, but Venus could be a very interesting destination as well for us. So,
why do you think Venus? Because we got some attention, and talking about the phosphine and the recent findings, in which, of course, talking too soon probably about that, but look, we get excited, as I told you. We get excited, we talk about stuff. It's aliens are up there, and it's okay, it's different. So right. Why Venus?
You have to look at the size of the planet. It's very similar to Earth. You have like 0.9 gravity there, right? So like the 90% of Earth's gravity, and at like around 50-60 kilometers altitude in the atmosphere, you've got temperatures and atmospheric pressures that are pretty much equivalent to the temperatures and atmospheric pressures you find on the surface of Earth, right? So if you can, engineer a balloon or some sort of aerostat that can fly around these altitudes, you could be very well living on Venus, right? There's of course the presence of sulfuric acid. Yeah, that's there in the atmosphere, and you have to protect from that in a way, but it's probably not as severe as it's not like it's going to melt everything, right? You can find a way how to protect your balloon from being impacted by this, and I think it's not a reason not to go, right? And when we have this sort of temperature range and we have this sort of atmosphere, of course you have to ask a question, should we be studying some microbiology there and looking for that sign of life that, as you said, maybe was a bit too hasty to announce before, but it very well could be there. We just don't know, because we haven't looked it in the right way. And always when you send humans, they can do a wider range of tests. They can adapt flexibly to whatever they find. They can perform tasks that would have taken several robotic missions and several dedicated instruments, to perform. They could be just there collecting samples, doing their research, looking for things, adapting their mission based on what they find. I mean, they're humans. They can do things better. They're more capable, and of course, they could be bringing things back to Earth for further study.
So do we
Yeah,
have anybody looking towards Venus now? Any companies or agencies?
I think Rocket Lab said that they want to make a vehicle that will be able to reach Venus. I think that was still when they said that they don't want to build human capable vehicles, but then their CEO ate his hat because they started building a human capable vehicle. So the question is, are they trying to get humans to Venus?
Mm.
Is there any correlation between these two
Yeah.
directions they've taken? So maybe.
Interesting. Okay. Yeah, so there's a lot going on again in the space industry, like Mars is being, as I said, biggest topic probably for now. So do you believe we should be looking towards anything else? Because again, I love just every time I go on NASA's website and they have the dedicated website towards exoplanets. And again, from all of those 4,000 plus exoplanets, we have about 1 point whatever percent of that are in a habitable zone. So do you believe at some point, or maybe again, looking from a kind of engineering perspective, because now we're working on a nuclear propulsion systems, just different things. And again, it seems like we live in this day and age, like where technology is being part of us, like every day, like we talking virtually now, like through this equipment, and it's being like a lot of that is being developed because of the space, exploration because of that. But it feels like we're on the edge of like breaking through moments when it comes to space exploration. So do you believe like going to exoplanets at some point, even like robotically, it's going to be something that we're going to do soon? What do you think?
I think it's just a question of opportunity, right? There's already several studies and proposals for light sails, where you use the it literally looks like a sail, and you use light to give it the energy to push it. Yeah, and if you had a focused laser from Earth, you could be pushing it towards
Oh, I've seen it, yeah.
speed, yeah, towards speeds of light. So, and then we're talking of a really small kind of a satellite type of mission, right? With this kind of propulsion, but of course, you could be trying to propel it in any of the directions to reach destinations that are maybe out of reach for human crews or for a more conventional type of missions. But yeah, of course, that's probably going to be an undertaking for generations, right? Or for at least for generations of engineers. So maybe several decades, because right now I'm not aware of any spacecraft that's capable of this, and just developing that is at least a couple of years of effort. And then, of course, flying there, even at the speed of light, which is not going to be that, it's several years. And that's just to the nearest star, right? And of course, many of these exoplanets are much further out. So we're talking maybe hundreds of years of travel at near light speeds. And then, of course, all this information has to get back to us, which is going to be at light speed. So you can pretty much double that.
Yeah.
So I don't think we'll be around to see it, so I don't like to think about it too much, because it's almost a bit it's a bit existential crisis inducing. But I like to look at the moon and places where we can set foot.
Something closer that you can see with your own eyes.
Yeah, just to keep it on a positive note, we could be looking at the Jovian moons, for example, because a lot of them might have water on them. There could be oceans under the surface, and what we know about water is that there, from the planet with liquid water, we can tell that we have liquid we have liquid water, we have life. So maybe something similar could be existing on those moons, and we just haven't looked yet.
Yeah.
So
well, all of these moments, like all of these missions, like where we have these missions looking for something for life, from extraterrestrial life, and most of the time it's going to be dedicated, of course, to microbial life. So that's awesome. Again, we have Perseverance, as you talked about, Europa. Maybe something is out there behind all this ice, and hopefully, again, if there's war, as you said, we're going to find probably something out there. What do you believe, again, just looking, I don't know if you can talk about, like, with a lot of people who are working in all of these positions, when I start talking about aliens, they're like, oh, there's nothing there. There's nothing. Just stop the, like, what's your personal view? Just look, it doesn't have to be yes, no. I just want to get like your personal thoughts. Like, do you believe it's something more advanced out there, somewhere deep in the cosmos, or we are the kind of the ultimate of what the intelligence is?
I think you're again inching closer to the existential dread level of kind of discussion, and I'm not sure if I want to go there. But yeah, just judging from the, okay, two things. One, you have to realize the vastness of the universe, right? Like even things that are kind of close in, when a physicist tells you that this is close, that's still really, really, really far away. And yeah, I mean, if you look at how long we have been broadcasting to space, like since the invention of radio, it's a very short time that we even have any sort of footprint in space in this sort of kind of communications in the level of communications, right? So we are just like a tiny little blink so far in space, and if this is the same for every other intelligent civilization out there, if there are any, we might not hear from each other in a very long time, and then even if we do, we might not be able to notice it, right? We might not be able to interpret that sort of signal. So again, as I said, existential dread. But yeah, it's a huge place to really draw any conclusions, and I think the level of uncertainty is so large that any answer is potentially wrong or right. It's just impossible to say.
It's something that we can debate, with the marshmallows and a fire outside, when we're camping, and looking at the stars.
Yeah, it's just, I think we just have so little information that it's pointless to even hypothesize what's possible and what's not. But that's what makes the discussion about the microbes much more interesting, right? Because right now we are the only life we know of in the space that we know of. So, finding something even tiny and potentially insignificant in the soil of Mars or on one of these moons, as I mentioned, that would be huge, right? And that would mean that life is a process in space. It's something that occurs, and that would maybe then tip the scales towards the hypothesis that there probably is some intelligent life, because now we have proof of life being a mechanism, and therefore maybe it has evolved somewhere, right? So yeah, so that would be some information that would maybe tip us in one of the directions. But right now, I don't think we have any information except for the lack of information, which I don't think it's a great thing to go off of.
Exactly. So look, when we're talking about mechanical, human, like one of the things that you're having experience in again is working with AI. And again, this is becoming another big topic, in the industry. So do you believe like this is going to take a big part in the space industry as well? Because I know, like, I spoke with this girl. She's going through analog missions right now, and she's in Europe, and she said, whoever's going to get picked for that, for the positions is going to be determined on AI technology who looks at different variables, and basically that technology will decide who will be most suited again to go further with this training. So that is being used there. Again, I'm pretty sure NASA is using, like, space industries, private companies. So where do you think this AI can expand, like on what level, and how can it benefit us?
Right. So you can, of course, automate things, and I mean, as someone who's worked with it, I look at AI more as a tool that's been fed some sort of knowledge by humans rather than something that's self-sufficient. That's really sci-fi, let's say. Yeah, like it's more for now, of course, but where we stand right now, it's more of a kind of a detection or like decision making tool. Yeah. And as you said, you could use it to select people, but I'd like to think that right now we're not at the stage so far where we have to resort to AI algorithms to filter out astronaut candidates, for example. If this is where this discussion was going, because I mean, the success rate is so little, it's so low, right? You don't have enough data to really gauge what is a successful astronaut, because out of 10,000 people you get maybe 6, and that's not because there are only 6 suitable people for the job. That's because the agency only has funding for 6 astronauts. Yeah. So right now, I think once we get to the point where we have a huge interest in positions, in astronaut positions, and at the same time we need a lot of people in orbit, then absolutely I think it makes sense. I mean, companies already do it in a more mundane, let's say, positions, where you have a huge volume of people coming in and out, and you maybe don't have the HR department of the scale to be able to deal with all this. So that's definitely something for the future. But I think right now it's too early, especially for these kind of jobs, which are very rare and very handpicked, let's say.
Yeah.
But the automation also comes in many different aspects, and of course, different groups are interested in different topics, and a lot of this is also being done not only by agencies but also by different university teams and different academic teams. So what we could be automating is the onboard operations, right? If we have a satellite that's monitoring something on Earth, we could be using AI to detect maybe some features on Earth, right? I think NASA had a CubeSat that was tasked with looking for volcanic eruptions. So they trained it on a set of pictures to look for the smoke basically coming out of the volcano. And the satellite would then basically start monitoring if it detected that in these last couple of frames, you have what looks like a volcanic eruption. So, you take off some of the load of the team on the ground that would have to otherwise go through all the data that the satellite captures and look for these features. And yeah, there's of course a debate: should you be running this AI on board or should you be running it on the ground? But then maybe your kind of mission wants to optimize what kind of data you collect, because maybe in the downtime when you're not detecting eruptions, you're looking for something else. So, it's a good way to maximize the effectivity and the efficiency with which we use our space assets. That's just one example, right?
Yeah. Oh yeah.
Same goes for driving rovers on planets. I mean, right now, NASA has a huge expensive rover, so of course they don't want to hand it over to an AI algorithm that may be not so reliable, so they drive it from the ground. But once we have, if the Artemis program is a huge success and we have companies interested in setting up infrastructure on the moon, if they want to prospect for water, are they going to be driving hundreds of rovers with teams of 10 to 15 people each from the ground? And I mean, just count those salaries and that's a huge budget, right? Or do you just pay the money up front and make an algorithm that will be able to, autonomously drive around a flock of rovers and look for this water, without any sort of human intervention? It's again a trade-off, but it's opening more doors and more potential solutions.
Gotcha. So yeah, definitely. So it's not always black and white as we talked, before.
Of course, yes.
It depends who you talk with. Like, I heard many interviews from Elon Musk, and somehow, because he's all over the news. Like when I particularly seen him talking on this podcast, and when he talked about AI, it's like the world, like the Terminator scenario, basically, where the world goes to end, nobody's just controlling it. And once the genie is going to get out the bottle, it will be way too late, to control it. And, I'm trying to think about that. I'm like, okay, we have the AI technology, which is, it's kind of on a brink of becoming some new thing. Hope maybe, because I'm not in the industry, so I don't know how advanced it could be. And then combine that with the technology as we have the crypto coming up and people talking about this is going to be a next currency, next thing. So combine those two, and suddenly you don't feel very kind of, like in control of, what's going to happen in the future. But look, it depends who you talk with. Again, if we talk with a person just like you, it's super exciting. The future is going to be good. We're going to have plenty of rowers rowing around. They're going to be looking for water, which of course is going to be that. Like they're going to be used for a lot of good, which again, it's being used right now for a lot of different things, so, in the space industry. So besides all of these things that we talked about, you as an engineer, besides looking at the moon and thinking about the moon, the mission's going to happen there. Like you as an engineer, what other projects in the industry, future projects, current, makes you excited the most?
I think we touched most of them already, right? The new space stations, I mean, to me professionally, it's extremely interesting just because of what we've covered already. How are they going to approach the topic? How are they going to use the station? And again, I said, I look at the moon and I would like to, this is one thing I would like to see within our lifetimes, and that's a permanent presence on the moon, the same way we have bases in Antarctica, what's stopping us doing the same on the moon, and understanding how we can live in this kind of environment, and then we would be able to answer all these questions that you also asked me about the project we did. We of course are using research knowledge from similar projects and from analogous situations that we know from the space station and from from Apollo missions and similar, but you know, nothing beats really getting down there and building some sort of outpost, you know, and having people live there long term. You know, that's probably the most exciting thing without inducing that existential you know, dread, and also without going too sci-fi with things that, you know, might end up being in a disappointment because we don't end up seeing them within our lifetime. So yeah, this is something that's I would say moderate enough in expectations, but also super exciting because it's not been done yet, and it's literally living on another celestial body, you know. So yeah, that's you know, just pushing those humans further out into space, and you know, making them stay there, and setting up a foothold, and then going even further, you know, step by step. But each step is exciting.
That is awesome. That is awesome. So again, look, you're 29, just starting your personal journey in this industry. Again, congratulations on that once again. It's going to be beautiful. And again, thank you for giving all the advice, inspiration for people to keep persevering, keep refreshing that feed on a job section to make sure that you're going to find something. Look, maybe you're, you know, maybe it's too early to ask you where you are personally in your life in a cycle, but regardless, I want to ask you, like, where do you think, or how do you think your personal like legacy, or what type of footprint do you think you're going to leave for the next generation, for, you know, to come?
You're again tiptoeing around existential dread very closely.
These, you love these questions, I know.
No, of course I'm joking, but I think, I mean, what I really like right now, I mean, is the human space flight aspect of the space jobs. Yeah, like really being close to the astronauts, and being close to this effort of pushing this boundary, as I talked about several times. You know, that's really, you know, it keeps me going because it's really interesting, and I think it keeps a lot of people who are both in and out of the industry. You know, this is what these are the news that people look for. You know, like you said about how space is going to be the next thing, but it already is to a degree, right? We have fancy satellites that can do a lot of very complex work. You know, we have more information about the planets than we ever had, but really it's, you know, the space station and the astronauts that make the news, you know, and that keep people exciting, and I guess to a degree, you know, keep the interest in the other projects as well, because you know, it's part of the same sphere, you know, part of the same sector. So yeah, it's good for keeping the enthusiasm, and it's good for keeping people interested in all aspects of the work in space. And where's my position in all that? Well, I hope I will be able to remain in this human spaceflight sector, at least for the foreseeable future. I mean, it's very exciting to be in it, and with all the upcoming projects we discussed, it's a great time to be joining the ranks of these people. And yeah, as I said, I'd love to see a lunar base in space in our lifetimes. And well, if we get to the point where it's feasible for, you know, regular people like you, like me, you know, to hop on a spaceship and, you know, take a holiday around the moon at some point, that would be fantastic.
Yeah, that's exactly what makes me excited about the space industry. You know, just like, okay, let's stop talking. Let's make things happen. I want to see this thing coming up, which again, as I said, it's probably the closest mission that we have chance to pull off. Again, having bold goals, again, flying to Mars or exoplanets or wherever, you know, in that kind of realm, it's great. But having something close that we can see, again, and you know, we have everything kind of in line, we have everything planned out, and it's really achievable. We can not even picture it, have it in a sci-fi movie, like we can actually go there because we've been there before. It's not like Mars, okay, what's gonna happen there, we don't know. Perseverance showed us the photos, it looks great, let's go and try it, you know. So this is really great, and I love what you said, that we take everything for granted, which again is a good sign. Again, the reason that we're talking right now is because of the satellite connections, and you know, but so we, you know, it's really like just having that refreshing kind of perspective that we really take it for granted. We have the space station, we have satellites flying around, we're looking to provide even more satellite, you know, internet connections to the people, which are, of course, as you know, there's a lot of people who still don't have it. And of course, in those countries, I'm pretty sure there's a lot of really smart, intelligent people that can, you know, come up the ranks really fast once they have that access to the, you know, to the internet. Because now these days you can build a lot if you have internet connection, a laptop or a phone. So look, everything is really, and again, the benefit that we're getting from all the research from ISS and space missions. So it's really great. The time is already here, as I said, so that's what makes me excited as well. So look, again, I appreciate you coming on today. It's been an awesome pleasure to have you on. And again, thank you for sharing all the great tips, giving a lot of some sneak peeks behind the curtain stuff. I know a lot of it's sensitive, you cannot share, but look, still, I appreciate you coming on. You're welcome to come back anytime if you want to. Look, I wish you a lot of great success in the future with what you do. And I know you will come a long way, even though you don't like to talk about long time frames. But look, I'm pretty sure you're going to leave a good legacy behind you. So
thanks so much. And thanks for having me. It was good fun.
thank you. Thank you. Look, guys and girls, I hope you enjoyed this episode as much as I did. So one thing that I want to ask you, if you share this episode to your friends, I just want to send them this message because I think it will open up their own personal perspective, views of what's happening in the space industry. Look, a lot of people during these times are looking to shift from whatever they're working on as a, in a career. Maybe they work in a medical field and kind of doing the law. So I think this is a good time for them if they're thinking about that switch. Changing their career, maybe they're an engineer, they can apply pretty much the same things, again, with the perseverance, with more information, and apply that in the space industry, which of course we need so many more people to get involved, because again, having a lunar base or going to Mars, that means, millions of people working collaboratively to achieve these projects. So make sure to pass this message. And as always, guys, I'll see you next time. And until then, don't forget to keep exploring.